Okay, some more problems from section 5.1, and this is number 21. And we've got the tangent squared of t over the secant of t, and we want to show that that's equal to the secant minus the cosine. So we've got two terms here, one term here, and I can separate this. Now remember the tangent squared, that's part of one of our Pythagorean identities also. Again, I'm not too sure what it is, so we'll just start over here and we'll kind of see what's going to involve the tangent. So I know the sine, this is the one I know, the sine squared of t plus the cosine squared of t equals 1. All right, I know that. I want to get the tangent, so I'll divide by the cosine. So I'll divide everything there by the cosine, and then I get one of my identities here. So this is going to be the tangent square root of t plus 1 equals, and 1 over the cosine is the secant square root of t. And then this is just a tangent squared, so I can just subtract 1 from both sides. So I have another form of this identity. The tangent square root of t equals secant square root of t minus 1. That's my identity. So I can rewrite this. So instead of writing the tangent square root of t, I'll write this. So this equals the secant squared of t minus 1 all over the secant of t. Don't know. Now, this is the secant squared over the secant, so that's going to give me a secant, and then I've got 1 over the cosine, 1 over the secant, that's the cosine, so I can probably see how it's going to work out. Doesn't look too bad. So I'll just break this up. Remember, when it's tough, break it up. And look what we've got. On the left side of the equal sign, we've got one term. On the right side, we've got two terms, so we don't want to go from 2 to 1. Here we want to go from 1 to 2, so the easiest way to break it up, go backwards. Before we were going from 1 by getting a common denominator, making one fraction. Now we're going the opposite direction. So I'll break it up and I'll write the secant square root of t all over the secant of t minus 1 all over the secant of t. And the secant squared, that's the same thing as the secant times the secant, isn't it? I can write it above here. That's the same thing as the secant of t times the secant of t. And then one of these will cancel, won't they? So all I have left is the secant. So over this just becomes the secant of t and minus. And then what's 1 over the secant? The cosine. And that is equal to what we wanted, the secant of t minus the cosine of t. So put a little check there and you're done. That's 21. Okay. Alrighty, hope that makes sense. Take a look at that. Should make sense logically on how we're working these. Now, there's lots of ways to do them, and you can always try to get them all in terms of sine and cosine and work it along those routes. But if you look at these and you start to kind of see how these things work out, remember this tangent has got secant. Now you've got, use your identities. I'm not looking at the identities, but you have them there to look at them. So try to see where you can put those in and substitute, and then you don't have to do all this deriving stuff. You can just you would probably just start with this as one of the identities and just solve it for tangent, and then you see that you can put that in. And then it eventually kind of all falls in place. All right? So that's number 21. But there are other ways to do it. You could, like I say, put everything in terms of both sides in terms of sine and cosine, and that would also work. Okay, 23. Okay, 1 minus the cosine of theta over sine of theta. We want to show that that equals cosecant minus cotangent. So it's kind of like the last one. Well, not quite, because we got, let's see, this is cosecant of theta, CSC, pardon me, of theta, minus the cotangent of theta, a lot of C's here. Alrighty, let's see here. Well, this has got one term, this has got two terms, so I can break it up. And I'll just see where that takes me. So this is 1 over the sine of theta minus the cosine of theta over the sine of theta. Don't know. But what's 1 over the sine of theta? That's the cosecant of theta, so that's, I've got it. And what's the cosine over the sine? That's the cotangent of theta. So that's all there was to that, so that was pretty easy. I can write it over here. So there's your identity proved. Okay, so that was actually easier than some of the other ones. Number 25. Okay. Sine of t, cosecant of t, plus the cosine, 25, cosine of t over the secant of t equals 1. So I'm going to try to get maybe cosine squared, sine squared, do it something like that. So what we'll do is we'll move this over here, so get everything in terms of the sine. And another way to write this is the sine of t times, and then I could just say this is 1 over cosecant of t. Is that all right? Can I do that? I could just break this up. In other words, if you just put this over 1, that would be the sine of t over the cosecant of t. So I just broke it up into two different little sections. I'll do the same thing over here. Cosine of t, that's over 1, times 1 over the secant of t. And does that equal 1? Now what's 1 over the cosecant? Isn't that the sine? Yeah. So this is the sine of t times the sine of t. I think you can see where we're going with this. And this is the cosine of t times the cosine of t. Does that equal 1? Well, that's a sine times a sine. That's a sine squared, right? Sine squared of t plus a cosine squared of t, because that's cosine times cosine. What does that equal? 1. Sure, that's our favorite Pythagorean identity. Okay. And, okay, we got a couple more, so we'll do those next. Hopefully those help. Try to think through them.